Hey everyone, so this is going to be lesson 3 where we're going to continue talking about these uh, extra exponential laws. In particular, we're going to talk about how to solve equations with common bases. So like always, my recommendation is to try to answer some of these questions yourself before you watch my video. So the first set, we have these do now questions. This is just a quick recap from what we talked about before. So in a case like this, the idea is that you want to try and think about what numbers you can plug in for x so that we get the final answer. So for example, for part A, I know that 2 squared equals 4. So that means in order to solve this, x has to be equal to 2. Over here, 3 squared is equal to 9, which is not 27. If I multiply that by another 3 and do 3 cubes instead, that equals 27. So here, x is going to be equal to 3. Over here, so I know 25, I know 5 squared is 25. But notice that in my example for part C, I'm looking for 1 over 25. So in order to actually get this as 1 over, the 5 squared has to be 1 over. And remember, with exponents, having a number in the denominator is the same as having a negative exponent. So what I get is that here, x equals negative 2. And then over here, same thing. So here, the exponent is now on 16. So if I made a number, 16 to the first power is 16, 16 squared is going to be some number significantly larger, 256. So obviously it can't be a number like that. Well, if I think about it, I know the square root of 16 is 4. So I just need to think about how do I make an exponent from the square root? As we talked about before, a square root is really just a fraction, 1/2. So in a case like this, x is equal to 1/2. All right. So going down here to the actual lesson, here an exponential equation is now is what we refer to an equation where there's going to be a variable on the exponent itself. Now, in the case where we have common bases, we know that the exponents have to be the same. See, in the do now, what I was basically saying was when I said 2x equals 4, I was saying that, well, I know that 4 could also be written as 2 squared. So because these now have common bases, I know that their exponents also have to be the same in order for this to make sense, which is where I got x equals 2. So that's what we're going to do here. We're going to set the exponents equal to each other. That way, if they have common bases, the exponents also have to be the same. So because my bases are now 9, I can just say that the exponent for the one on the left equals the exponent for the one on the right. So if I solve this, I move the 2x over by subtracting it. This becomes just a regular x. I can add the 2 over to the other side. And I end up with x equals 3. Of course, it's always good to check. They even want us to verify. So we'll do a quick check over here. So 9, 3 times 3 minus 2. 9, 2 times 3 plus 1. 3 times 3 is 9 minus 2. 2 times 3 is 6 plus 1. 9 minus 2 is 7, and 6 plus 1 is 7. So I end up with 9 to the 7th equals 9 to the 7th. So right there, my answer is 5. Now we get to this one. Here, the bases aren't the same because 27 isn't equal to 3. So what I have to do is I actually have to rewrite 27 so that it's a power of 3? Well, again, 3 to the first is 3. That's not 27. 3 squared is 9. That's not 27. But 3 cubed is 27. So I'm going to rewrite this equation as 3 cubed times x to the power of x equals 2x minus 1. And remember our exponent laws? Since the x is on our outside of the brackets, this is actually can be rewritten as just 3 times x. That was the power rule from the first lesson. Now that I have the same bases, I can set the exponents equal to each other. So move the 2x over to the other side, and I end up with x equals -1. Of course, it doesn't say it. We'll do a very quick check here. So 27 to the -1 equals 2 to the -1 minus 1. This is just 27 to the -1. And this ends up being 3. 2 times -1 is -2. Minus 1, which can be rewritten as 3 to the -3. If I plug this into the calculator, 27 to the -1 power is 0.037. And if I plug in 3 to the -3, I get 0.037. So again, I get the exact same number. So whether or not you have the identical bases right from the get-go, or you have a base that could be rewritten as another base, you're going to need to make sure that you get them the same before you can start solving. All right, so here's the next one. Now, in this third example, as it says on the side, is that 8 doesn't equal 32. So 8 to the first is 8, but 8 squared is 64. Now that doesn't work, but I can rewrite both terms as powers of some other number. This actually requires you to know your powers of fairly small numbers. Powers of 2, powers of 3, powers of 4. 2 to the third power is equal to 8. And I can do the same thing for 32. This should be to the power of 5 equals 32. So this equation can be rewritten as, instead of writing 8 to the x, I write 2 to the third to the x. And instead of writing 32, I write 2 to the fifth. Using my power rule from before, this just becomes 2 to the 3x equals 2 to the fifth. So bases are equal. Now I could set the exponents equal to each other. And I get x equals 5/3. We could check this if we wanted to, but like I said, you could just plug it into your calculator and you would see that doing 8 to the 5/3 does equal 32. So that's pretty much it. Obviously, you want to kind of keep an eye out for what numbers you can and can't do that trick with. Like I said, sometimes you'll have the bases equal right from the beginning. Sometimes it'll just be very evident that, oh, if I squared that term or if I cubed that term, it would be equal to the other base. But there are going to be some, like in this case, C and D, where you're going to have to play around and think about what numbers would be the best thing to kind of substitute in for that. All right, so starting from here, I'm not going to touch the 3, but I am going to rewrite the 9 as 3 squared. Bases are the same, so set the exponents equal to each other. Now I'm just solving a quadratic. So there's a multitude of different ways. I'm going to go with the factoring method. One thing that I mentioned to people in class is that a lot of the times when we're doing these more complex questions, questions that aren't just factor this, but where factoring ends up being a minor part to the whole problem itself, you'll find that the factoring aspect should be fairly easy, that you should be able to immediately factor it using the addition multiplication method. So from here, we get x equals 1 and -2. Again, I highly recommend that you check out both these numbers, but we would see that 1 squared plus 1 is another way of saying 3 squared, and 2 squared plus -2 will also get me 3 squared. All right. From here on out, I'm not going to check my answers, but you should get into that habit of making sure that you just quickly, double check to make sure that the numbers plug in properly. All right, so for here, once again, I'm not going to change the 3. I'm going to leave it by itself, but I am going to turn the 27 into 3 cubed. Using the power rule, this becomes 2x plus 1 equals 3 to 3x. Set the powers equal to each other. All right, and then solve. So we move the 2x over. And I get x equals 1. Circle that answer too. All right. Going down here. Now again, as I said before, 9 squared doesn't equal 27. There's actually nothing I could do to 9 to make it equal to 27. So instead, what I'm going to do is I know that 9 can be rewritten as 3 squared. And I know 27 can be rewritten as 3 cubed. Using the power rule, I'm going to multiply 2 with the powers on the outside. So 2 times 3x is 6x, plus 1 times 2 is 2. And then over here, 3 times x is 3x, and 3 times 2 is 6. Now I have equal bases, so I get 6x plus 2 equals 3x plus 1. Subtract the 3 over, subtract the 2 over, and we end up with 3x equals 4. Divide both sides by 3, and I get x equals 4/3. For D, similar thing. There's really nothing to relate 81 and 27. So instead, I'm going to do something very similar to C, except instead of writing 81 as 3 squared, I'm actually going to write it as 3 to the 4th. And this is also still going to be 3 cubed. Once again, I'm going to multiply these two bases through the power rule. So this is going to be 4x plus 8. And this is going to be 10x plus 8. So now I have the exponents being set equal to each other. So, oh wait, sorry, this is cubed. So this becomes 15x plus 12. So now the exponents can be set equal to each other. So subtract the 8 over, subtract the 15 over. So I end up getting negative 11x equals 4. On both sides, and I get x equals negative 4 over 11. So kind of a bit of a weird answer, but that's what you end up getting. All right. So continuing on to the other examples. So once again, other examples where we're doing pretty much the same thing. So here, I'm going to rewrite the 9 as 3 squared. Set these exponents equal to each other. Add the 5 over. Divide both sides by 2. And we get x equals 7/2. All right. Over here, we end up getting so 16 as a power of 2 is going to be written as 2 to the 4th. Setting the exponents equal to each other. Subtract the 7 over. You end up getting -3. Divide both sides by 3. And get x equals -1. Over here. So this one's going to be a little bit trickier. So rewriting 125 as some power of 5. I'm going to write it first like this. So 125 is just 5 cubed. Because the 5 cubed is in the denominator on the right side, but not on the left, I need to actually use the negative power rule, bring it back in the numerator, and flip the sign. So I'm going to set these exponents equal to each other. 4x minus 5 equals -3. So add 5 to both sides. And I get 2. Divide both sides by 4. And I get 1/2. Okay. Down here. So this one at first may seem a little bit tricky because you might think that there's no power of 1 that would equal 5, because any power of 1 is just equal to 1. But if you remember, there is a power of 5 that does get you 1, 0. So this is written as this equals to 5 to the 0. Setting these exponents equal to each other, I can then add the 2x over. Actually, I don't want to add that 2x over. I actually want to factor the x out. And I end up with 2 solutions. X equals 0 and x equals 2. Yeah. So both of these are the correct solutions. If you had moved over the 2x like I did, you would have divided out the x and only gotten one of the solutions. But the key thing here is that 0 is actually also a proper unit. All right, so here, what we're going to do, we're going to actually have to rewrite both of these as powers of 5. So 125 is just 5 cubed. And 1 over 25 is 5 to the -2. Because remember, 25 is 5 squared, but because it's in the denominator, I have to make my exponent -2 in order to kind of reflect that. So fixing the exponents with the power rule, we get 3x over here, and we end up getting -8 plus 2x. So setting these exponents equal to each other, subtract the 2, and I get x equals -8. Okay, down here, So same thing that we've been doing before. So this stays the same. 125 is actually 5 cubed. Fixing the exponents. Setting these exponents equal to each other. And end up with x equals -3. For part B, so this can be rewritten as 4 squared to the -3x. And the 64 can be rewritten as 4 cubed. This simplifies as 4 to the -6x, setting the exponents equal to each other. You get this, which actually simplifies to 1/2. All right. So there's no way of getting 4 getting 8 as a power of 4. So this is actually rewritten as 2 cubed and 2 squared, which simplifies to this. Setting the exponents equal to each other. Divide both sides by -1. And I get x equals -2. All right, over here. So this one is definitely a lot messier. So you're probably going to have to play around with this and try and think of numbers that you can, divide into here. So let's see. I'm just trying a bunch of different numbers. All right, so it took a little bit of time, but I found the numbers. 216 can be rewritten as 6 to the 3rd. This is probably a little bit bigger of a power that you would have normally seen. And then this can be rewritten as 6 to the -4. So fixing these exponents, I end up getting this. Now setting them equal to each other, 3x minus 6, -12x plus 8. So add the 12 over, add the 6 over. 15x equals 14. Divide the 15 over and we get 14 divided by 15. And that's it for those questions. I just want to scroll down. All right. So there is these next 4 questions. So here it says 100 must be raised to what power in order to be equal to 1,000,000 cubes. All right. So our first step is to take this word problem and try to rewrite it based off what they said. So 100 is raised to some power, and it has to be equal to 1 million, so that's 1, 2, 3, 1, 2, 3 cubed. So to get common bases, the 100 can be rewritten as 10 squared, and the 1 million can be written as 10 to the 6th cubed. So this is basically saying that 10 to the 2x equals 10 to the 18th. 6 times 3 is 18. So 2x equals 18. Divide both sides by 2. X equals 9. So the answer is that 100 has to be raised to the power of 9. Going down to here. All right. So here they want us to determine the intersection of these 2 points. So remember, as it says here, that because these are intersecting, that means that their y values have to be the same. So what we can say is, instead of having them separate, we're looking for the point where this number equals this number. I can rewrite this as 2 cubed, and this number is 2 squared. Fixing the exponents would be 3x minus 3, 4x minus 6. Setting the exponents equal to each other. Add the 3 over. Subtract 4 over. I got negative x equals negative 3. Divide the negative out. And we have x equals 3. So, yes. Now, actually, I need one more thing because they want the intersection point. The intersection requires both an x and a y point. So now that I know that x equals 3, I have to plug it back into one of these equations and figure out what I get. So 8 squared is 64. So my intersection point would be 3 comma 64 when x is equal to 3 and y equals 64. All right, here, so they want to determine the zeros of this exponential function. All right, I don't, oh, okay. So what we're going to end up doing, I was a little confused with what they're writing as the steps, but they were basically saying that instead of writing as fx equals whatever, just simplify it as y equals minus 9 minus 32. We're going to set y equal to 0 because that's what they want us to do. And then we need to kind of move things around. Like we need to get only one term on each side. So this 32 has to actually be added over. So we get 32 equals 2, 2x minus 9. 32 can be rewritten as, sorry, not 3, 2 to the power of 5. So we get 5 equals 2x minus 9. Add the 9 over. And we get 14 equals 2x. And we get x equals to 7. Yeah. And like I said, we can always double check to make sure this makes sense. And the very last question here. So they want us to figure out the values of x and y based off of these statements. Okay. So let's just do what we've been doing before. So this becomes 2y. 8 is just 2 cubed. So we get this, and I get y equals 3x. That's as far as I can go with that. So let's try out this other one. So we get 3y equals 3x plus 4. Now these are actually already had bases, so I can actually set their bases equal to each other. And that's as far as I can go here. But notice that I now have two equations where I have y equals something with x. So I can actually set them equal to each other, since this equals y and this equals y. And now from here, I can actually solve for x. And I get 2. And then I could plug this back into either one of these equations. I'll do it for this one. 3 times 2 is 6. So x equals 2, y equals 6. And that's it. So make sure that you finish completing these questions. And don't forget to submit everything. If you are absent or a virtual student, you have to submit the entire worksheet, every question, the ones we did, plus the closure and the homework. If you are a physical student and we're in school the day that we go over this, then you only have to submit the closure and homework. All right, if you have any questions, please feel free to let me know. Otherwise, good luck and have a great day.